Hello. In this video we will be talking about comparing two functions. So if you take a look at the example that's given to you right here, it says that water is pumped into two aquariums, P and Q. The tables show two functions relating the total amount of water, Y liters, and the time taken, T minutes, to pump the water into each aquarium. So what we should do right here is we should highlight all of our information right here. So total number of water is our Y variable. This is our independent variable. And then the time taken in minutes to pump the water into each aquarium is X. All right. Now, before I do anything, I want to know if my functions are going to be linear or nonlinear. So what I'm going to do is I'm going to see what the rate of change is for each one of my functions. So right here, this is going up by 50, and this is going up by 5. So the rate of change is 50 over 5, which is 10. All right. Same thing with this one. This one is going up by 100. This one is going up by 10. So the rate of change is 100 over 10, which is 10. And then the last set, we have this one going up by 100, this one going up by 10. It's going up by the same amount. So this one is definitely linear because the rate of change is constant. Okay? All right, now let's see how the next one looks. So in the next one, same thing. I'm going to figure out what my rate of change is right here. So my rate of change from 170 to 95, I just have to calculate what 170 minus 95 is, which is 75. So this is going up by 75. And this is going up by 5. So this rate of change is 75 over 5, which is 15. By the way, when I did the first examples right here, I should say that this is 10 liters per minute. Okay, so 10 liters per minute. And then same thing with the next one. It was 10 liters per minute. So this one right here, same thing, it's still liters, it's still minutes. So this one right here has a rate of change of 15 liters per minute. Okay, let's try the next one, see what the next one will give us. So this one right here is going up by, same thing, I'm going to figure out what 320 minus 170 is. So this is going up by 150, and this is going up by 10, which means that my rate of change is 150 over 10, which is 15 liters per minute. Okay, and same thing with this one's going up by 150, this one's going up by 10, so it's the same rate of change, which means that this is also linear because the rate of change is constant. Alright, now let's go ahead and answer each question. Number 1, write an algebraic equation to represent each function. So first of all, I need to make sure that I know what two things I need to find out. I need to find the m, and I need to find the b for both equations, and I know I can find m and b because I know it's a linear, they're both linear functions. Now, m is just your rate of change. So we could choose 2 points if we wanted to, so I'll go ahead and choose 2 points right here and figure out that my first point is 570 and my second point is 10/120. So I'm going to go ahead and figure out what the slope is. So 570 and 10/120. So the slope is going to be 120 minus 70 over 10 minus 5. So I end up getting 50 over 5, which means that my slope is 10 liters per gallon. Okay, or 10 liters per minute, sorry. But if you remember when we actually looked at our rate of change, we already figured out that it was 10 liters per minute. So we didn't technically have to do that because our rate of change right here, our 120 minus 70 gave us 50, our 10 minus 5 gave us 5. That's the y2 minus y1 over the x2 minus x1. So says liters per minute. It's not a 4, okay? So that means that my slope is 10 liters per minute. Now, all I need to do is figure out what my y-intercept is. So I'm going to use y equals mx plus b. And I know what my I know one of my coordinates. And I also know my slope. So I'm going to plug this information in. So I'm going to say 70 equals 10 times 5, because 70 is your y, 10 is your m, and x is your 5, plus b. So I get 70 equals 50 plus b, which means that B equals 20. All right, so once I've done that, that means that my equation is going to be y equals 10x plus 20. Okay, and then I can do the same thing for my other function as well. Now for my other function, I'm just going to look back and see what my rate of change was. My rate of change was 15 liters per minute. So I don't have to do anything to figure out the slope. I already know what the slope is, and I know that it's 15 liters per minute. So now all I'm going to do is I'm going to use y equals mx plus b, and I'm going to calculate what my slope is. So I'm going to use one of my coordinates. I will use 595. It really doesn't matter what it is that you use. So whatever you prefer. So again, I'll use 595. And I'm going to plug it into my formula. So remember, y equals mx plus b. You know the y is 95. You know the m is 15. You know the x is 5, and you're trying to solve for b, so plus b. All right, so again, this is plus b. So now I'm going to multiply this together, so I get 95 equals 75 plus b. So then I subtract the 75 from both sides, and I end up getting 20 equals b. All right. So I'm going to put this right here. I'm going to say this is 20, which means that my full equation for the second aquarium will be y equals 15x plus 20. Now here's the thing that's really important. You need to understand what this is saying, what this means. So first of all, we have to understand what x and y stand for. So let's go back and read what it says. Y is the number of liters, and and t is the time in minutes. So actually, when we go back right here, our final equations should be y equals 10t plus 20, okay, and y equals 15t plus 20. So here are my two final equations. So if t stands for time and y stands for the amount of liters, we will end up getting that the number of liters right here is equal to 10 gallons per minute plus an additional 20 liters. Okay, and here the number of liters here is equal to 15 liters per minute plus an additional 20 liters. So question number 2 says write the initial input and output values for each function when it starts. So let's do our separate aquariums that we have here. So we have aquarium P and we have aquarium Q. All right, and for aquarium P, our initial input value will happen when it first started filling up. So our initial time was at 0, time 0. And when the time was 0, the aquarium already had 20 liters. Okay, so at 0 seconds there were 20 liters. These are the initial amounts. So same thing with aquarium Q. The initial amount happened at time 0. So t equals 0 seconds. And this happens, when this happens, there were initially 20 liters of water in the pool. All right. Lastly, we need to answer question 3, which is which of the two aquariums is filled with water more quickly? That comes from my equation right here. This equation is saying that aquarium P is filling up with water at a rate of 10 liters per minute and aquarium Q is filling up water at a rate of 15 liters per minute. So that means, to answer question number 3, we're going to say that aquarium Q is filling up at a faster rate because it is filling up at a rate of 15 liters per minute as opposed to 10 liters per minute, which is a smaller number. Okay? All right, hopefully that made sense to you. Let me know if you have any questions. I will see you next class. Bye.